What's up to anyone? Just stopping by. Welcome to week 10, and we will be looking at some math questions today. So, yeah, once we get some people on, we will take a look. Most likely going to be calculus, but all subjects in high school are welcome. So just wait for people to join here, and then we will get these questions rolling. So, yep, to anyone joining in, we will look at some math questions. I'm going to start with, let's see. I guess I could just start doing some integration practice while we wait for people to get here, just so that the after recording will have some math. All right. So let's see, maybe some antiderivatives until I get something in the chat. So let's find the integral of 4e to the x, cosine of 4e to the x dx. So for u substitution, this is a complicated integral, but we have u equals, we should set u equal to the inside term. And from here, we're going to have du equals 4e to the x dx. So where this is coming from, as a side note, is that du dx is 4e to the x, and we're just basically multiplying both sides by dx. So then what that allows us to do is we could transform this integral. We're going to have 4e to the x times cosine of u. But now dx, what we could do is we could solve for dx by dividing both sides by 4e to the x. So we'll have du over 4e to the x equals dx. And now dx we can replace with du over 4e to the x. Notice these terms cancel out completely, and our new integral is just cosine u du. Now the antiderivative of cosine u is sine u plus c. And the last step, make a substitution for u. We're writing it back in terms of x. So here would be our antiderivative. Now, whenever you want to check your question or check your answer to these questions, you can always just take your answer and take the derivative. So for this, I know I'm correct if the derivative of our answer brings us back to the integrand, the term on the inside of the integral. So to take the derivative of the first term, we're doing the chain rule. Derivative of the outside is cosine, keep the inside the same, times the derivative of the inside is 4e to the x, plus the derivative of c, the constant, is 0. So this definitely checks out. All right, so let's see here. All right, so we have 2 people for now, so hello to whoever's here. And if there are any questions, specific ones that you'd like to see, just let me know, and I will do them. Otherwise, I'm going to pick random calculus questions to look at. All right, let's see more. Ooh, that one looks nice. Actually, yeah, that one's like not so bad. How about, yeah, I could do that one though. All right. So let's say we had this integral here. The integral of sine theta over cosine squared theta d theta. So this one, there's a few ways you could do it. The easiest way to do it, what's jumping out at me right away, is I'm going to call this sine over cosine. And of course, with the theta attached, leaving that out would make the expression meaningless. So we need the thetas attached. Sine over cosine is tangent, and 1 over cosine is secant theta. And then we're running out of real estate here, so we write a little smaller. So this is tangent theta, and this is secant theta d theta. Now from here, if you just recognize that the derivative of secant is secant tangent, then you're basically done, and this is just secant theta plus c. All right, so that's like probably the fastest way to do this, is just know your trig identities. Otherwise, if you don't recognize this, like option 2, what you could do is you can do a u substitution. Say u equals cosine theta, and then du is negative sine theta d theta. And then that would tell you that du over negative sine theta equals d theta. So now if we do the transformation on this integral, this is now going to be the integral of sine theta over u squared, and then d theta is du over negative sine theta. Now sine theta cancels like this, and from here we could rewrite this. Related rates, absolutely, silver ace. Sure can. Any particular kind you would like me to do? Because I could just grab a random one. So here, this is minus u to the negative 2, and this would be minus u to the power rule. We have plus 1 over negative 1 plus c. This minus minus cancels. And now this is u to the minus 1 plus c, but u is equal to cosine theta. So you see how this is 1 over cosine theta plus c, which is secant theta plus c, same answer. So related rates, absolutely. Meet the rates, they're related. I'm going to grab one from the problems book. So let's see here. I'm just going to, I guess I'll scroll, because for some reason when I go to do a word search, this thing gets angry. Wait, is this maximize, minimize? Cones or triangles? Okay, yeah, the cone ones are a little tricky. Let me... Oh, profit equals revenue times cost for related rates, please. Okay, so I could zoom around for one of those. Those are really intense. Those are very intense. I have a video on that. If you look up my Star Wars question, hang on. I gotta self-promote for a second. Oh, that's optimization though. Wait. Yeah, so maybe I'll browse around. Let me just see. Oh, here it is. All right, so I'll do one with cones or triangles. So you know what, the famous question here, let's see. All right, so I'll just jot this down, because so let's see here, a cone. I could use Smart Notebook. Let me see something. If I open, give me 1 minute to, maybe I'll open up one of my old lessons. Yeah, you know what? I'm going to do that for a minute. So hang on 1 second. I'm going to flip this display off. You know why? Because I made lessons on this 100 years ago. And yeah, I might as well just do that. Hang on, related rates. Area and volume. Oh wait, is that? Nah. All right, you know what? I'll just grab it from this book, whatever. Yeah, that lesson is not. All right, so all right, I'm back now. I'll go with this one. A cone. So let's, yeah, with the height of, so let's say the cone has a height 10 inches. With height 10 inches and radius 2 inches is being filled with water. Okay, so we have this. Whoops, a little sloppy here. So being filled with water at a constant rate. Okay, so at a constant rate. 84, yes, I will add that to the queue. At a constant rate of 2 cubic inches per second. All right, so now how fast is the surface of the water rising when the depth is 6 inches? How fast is the, all right, surface of rising, okay, and blah, 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 blah. Let me just make sure. When the depth of the water is 6 inches. Okay, so something like this. All right, so here we are. So now this, let's just hang on, get everything else organized here. All right, yeah, another, okay, just getting situated here. I just want to make sure if I could find a, oh, this one there is no answer key for, but whatever, we'll just be awesome. All right, now because sometimes there's like little traps in these, which I'll talk about, but I mean the general idea will be here. These cone ones are a little annoying, so okay, yeah, so we'll just continue with this. So my advice for these is draw it out. All right, so you have a cone, and you know the volume is 1/3 pi r squared h. So with related rates, the key is that you want to write your formula, and you want to think about what's changing and what's not changing. Now in this, the cone itself is not physically changing. What is changing is the water level. As water is being filled here, is making the height and the radius change. But one thing that makes these cone questions a little tricky is that whatever water level we're at, this radius over here and this height is proportional to the big radius and the big height. Okay, that's just a property of cones, that these triangles here, see, like if I change colors, let's say I look here, see this new right triangle, this one in pink is similar to the one in green. Okay, the original like big triangle. So that's like one of the ideas like right away. So the height of the entire cone is 10 inches and the radius is 2 inches. So then what that tells you is that whatever the radius and height is at any level of the water, the ratio of r to h is going to be equal to 2/10, which is equal to 1/5. So then that tells me that r is equal to 1/5 h. Like if we do times h on both sides. So that gives us this. And what we do with this is we plug it into the first equation. So now this equation modified is going to be 1/3 pi times r squared times h, but instead of r, you're going to replace it with 1/5 h. Okay, so that gets you here. Now, from this step, volume equals 1/3 pi, and we have 1/25 h to the third like this. So then what we want to do from here is this is going to be 1/75 pi h to the third. So then dv over dt, oh, so now at this step, so depending on how much we know with this, from here you're going to take the derivative with respect to time. So this is like where your chain rule step comes in. The derivative of v is dv over dt, and that's 1/75 pi, that's a constant. The derivative of h to the third is 3h squared, but we have to tack on dh over dt. That's the extra piece. Now, before we start like plugging stuff in and solving, they told us that at this step here, the cone with blah, 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 blah is being filled with water at a constant rate of 2 cubic inches per second. That's dv over dt. So that information they gave us they told us dv over dt is 2 cubic inches per second. And they're saying how fast is the surface of the water rising when the depth of water is 6 inches. Now, this is the part that's debatable. All right, the phrase like the depth equals 6 inches can, in like certain contexts here, but I've seen it like the question go both ways. It's like kind of annoying. Like if the height of the cone is 10, okay, the height of the cone is 10, that a depth of 6 inches could be like 6 inches going this way. So if this is 6, the height of the cone goes from the ground up. Okay, so what we have here is we would have a height equal to 4 inches. Okay, so that's how this part here would work. Okay, so that's like one thing that's annoying here. If they say depth of 6 inches, this could mean the height is equal to 4 inches. But I've seen books where they say like the depth is like not necessarily going from the top down. They're like just treating that as the height. Okay, so just know if it's like height equals 6 inches, height equals 4 inches, you're going to get a slightly different answer. But now we could replace, let's say we just go with height equals 4 inches. We would have dv over dt is 2 equals 1 over 75. And I'll write the units at the end. Pi times 3 h squared would be 4 squared dh dt. Okay, and then from here, just a matter of solving. This is going to be, let's see, 16 times 3 is 48. Pi over 75 dh dt. And then I would just multiply both sides by the reciprocal. So I would multiply by 75 over 48 pi. And dh dt, this is if h equals 4. So if h is equal to 4, we would have dh dt equals, and then 2 over 48, that would be 75 over, and that would make 24 pi on bottom. You could also divide the top and bottom by 3, and that'll give you 25 over 8 pi. And it would be cubic, height is just inches, so it would be inches per, was it seconds? So inches per second. All right, but if you just said h equals 6, then that would be like a different story. All right, so it depends, like sometimes they could be funny with that, but most of the time on the AP test, they're direct. They don't put it like depth and then go, ha ha ha, got you. That was actually a height of 4 inches, not 6 inches. So, yeah. It's annoying when it's like a semantics game. Like, all right, what are they actually trying to say? All right. Oh, okay. Yeah, it's like the same. Oh, one of those. Okay. So let me just see. So profit equals revenue. All right. So if it's something like that, let's see. So yeah, profit equals revenue minus cost. All right. So that's profit, revenue, and cost. Okay. All right. So what they're telling you here is construct the profit function. So that's P of X. All right. So there's P of X. And I'm trying to see here. They're telling you C of X. So let's see. Oh, wait, sorry. I'm bumping into my mouse. So it's like messing this up. So this is x to the third minus 4x squared plus 50 over x. Okay, and r of x is 50x. Construct the profit function P of x. All right, so P of x would be r of x minus c of x. So I would just negate all of these. Minus x to the third plus 4x squared minus 50 over x. Okay, and they're telling us that dp over dt is equal to, and we would have 4.544, and we're also told that dx dt is equal to 0.05. Okay, so with that information, what are we trying to find? Determine the x value when, so we have to find what is x equal to. So x equals blah, blah, blah. All right, for something like this, honestly, I would just say p equals, because that like p of x notation could just be a little bit in the way. So like we already technically constructed it, but that means dp over dt equals, and we would have 50 dx dt. All right, so we're essentially taking this and taking the derivative with respect to time of both sides. So we're going to have that minus 3x squared dx dt plus 8x dx dt. And if you could do this one fast, then great. Otherwise, just rewrite it and use power rule. Don't do quotient rule. Quotient rule will take, oh wait, why are you all connected? All right. I move this over. So plus 8x dx dt. And then this I would just say, all right, plus, oh wait, let me switch. Plus 50 over x squared dx dt. But if like we can't do that fast, just know like 50 over x, the derivative of this is the same thing as the derivative of 50x to the negative 1, and that's negative 50x to the negative 2. Okay, so that's why when it's like the derivative is minus 50x to the negative 2, minus minus becomes plus, and 50x to the negative 2 is 50 over x squared. All right, so we get here, and then I'd probably just factor the left side. Like, I was going to do that right away, but I want to skip too many steps. So 50 minus 3x plus, 3x squared minus 3x squared plus 8x plus 50 over x squared. Okay, so this gets us here. And then from this step, I imagine we like might be able to use a calculator for this, but I don't know. We'll see if we can do it algebraically, because these numbers don't look that polite. 0.05, and then you've got 50. Yeah, this is like a calculator situation, I imagine. Okay. So then from here, I would just divide both sides by 0.05. And then second trace in the calculator. So if I open up the calculator. Yeah, this question's like a little bit of a marathon. Let me like do this so I could swap out with a calculator. But yeah, it's a nice question. Yeah, I haven't done those profit ones. I haven't seen one like that in a while, so it's nice. Related rates are just kind of annoying. Like they're like very long-winded, and it's like sometimes like when they play like I gotcha, it's just kind of like just like all right, you got me. So good notes. All right. Now I'm just gonna solve this on the side. I'm assuming like the calculator stuff is okay. So I'm doing 4.544 divided by 0.05. That's 90.88. Okay, so this is 90.88 equals 50 minus 3x squared. Yeah, this is definitely a calculator. Unless you have a computer brain, this is not happening. All right. And yeah, I would just write like 90.88 in the first spot. And then that right side, 50 minus 3x squared plus 8x. And then plus 50 over x squared. Oh, wait, you know what? Let me put this part in parentheses just in case. Plus 50 x squared on bottom. Okay. And I will delete the other part. Let me just double check I typed it in right. 50 minus 3x squared plus 8x plus 50 over. Okay, so now I would graph both and make the y maximum go up to 100. And the x minimum, like, even like negative 20 to 20, just so I cover enough space. All right, so right now there are two solutions, but x should be positive because I'm guessing, let me see the question again. X probably represents like, what was it? Yeah, like probably the number of goods you sell. So I can't imagine like negative would make sense. So then I would trace the positive root. Second trace intersection, whoops, wrong button. Second trace 5. Here. It's saying x equals 1.1849. So 1.1849. So, I mean, let me reread the question. I don't know if I'm missing something, but that seems like profit is revenue minus cost. Yeah, so R of X is revenue minus cost is C of X. That's P of X. All right. Yeah, I mean, that's what I'm getting here. That's like they like 3 decimal places, so that's 1.185. So hopefully that shows up. Oh, wait a minute. I'm sorry. My display is not even showing. So yeah, X equals this. I got 90.88 on this side equals this. And then I just did Y1. So in the calculator, I did like, this is Y1 and this is Y2. All right. I don't think I'm missing something, or I hope I didn't copy a piece wrong. Let me check the oh, it's right. Yay. All right, cool. All right. I'm glad. What's like fun about this is I'm really just getting hard questions, and I have to be spot on the first time I do them. So there's definitely going to be a week where someone asks me a question and like I'm like I need time to think about it. But that's like totally natural. It's not like, once we get to a certain level, we just never get anything wrong again. Yeah, like I would wonder about that. This was like bothering me a little bit. Like this question, the depth thing, it's like I would just double check that, because like the way I look at it, it's not May yet. And when I'm getting close to May is when I have to get really sharp, because like my goal as the teacher would be, if I took the AP test, I would want to get a 108 out of 108. Like I would be aiming for a perfect score. That way, like, when I'm teaching, I'm ready to answer everything. All right. So that was 84, then 817. All right. So I'll answer in the order they were asked. So question 84 from the packet of fun, which I'm hoping it's fun. All right. Maybe not. No, I think it's like one of those love hates. Maybe I could call them love hate packet. No, packet of fun has a better ring to it. And that's been the name of it for like going on 7 years now. So, all right, 84, is it? Oof. Yeah, some of these questions are like just kind of nasty. All right, so 84 is like, let me see here. Let me expand this. So they give you a graph of f prime. And you're going from like this point to 0, 2 up to like, so let's see, 0, 2. All right, and we're going out to 4, 4 up here. And then we're going out here. So this is at 4 and this is at 6, and then we're dropping. And this is a graph of f prime. Okay. And they're telling us that f of 2 is equal to 10. Okay, then the local linearization of f at x equals 2. Okay, well, one thing that's jumping out at me right away is local linearization. When I hear local linearization, like linearization, I'm thinking like tangent line. Specifically at x equals 2. So this is our point. This is our point, but slope is going to come from f prime, which we have a graph. So f prime of 2, if we just look at the graph, is up here at 3. Okay, so f prime of 2 is equal to 3. And the way I know that is because like 0, 2 is on the graph, and this is the point 4, 4. So if I take the point 0, 2 and 4, 4 and I find the slope between them, that's going to be like 4 minus 2 over 4 minus 0, which is going to give us 2 over 4, which is a half. So like that line would be 1/2 x plus the y-intercept is 2. Like if I really wanted to be precise. And then the y value at x equals 2 would be half of 2 plus 3. But the bear trap here, plus 2, I'm sorry, I just like kind of was thinking the answer. So 1 plus 2 is equal to 3. So that's how I know like 2, 3 is here. But one thing to be mindful of is that y in this case is like referring to f prime. So this is like for this piece of f prime. But otherwise you just eyeball it, like f prime of 2 is equal to 3, because once again, this is a graph of f prime. So that's really big here. So now that we have this, we use the equation, like our point slope form equation. So we have y minus the y value equals the slope was 3, x minus the x value. So y equals 3 times x minus 2 plus 10. And what are they actually asking for? Like what's the equation? Oh, so then simplify this. 3x minus 6 plus 10 would be 3x plus 4. So choice D. I'm hoping I didn't mess up. Let's find out. Yay, it's right. Cool. All right. Hope that helped. All right, 8 and 17. So rewinding back. All right, so the best approximation, blah, blah, blah. So a sphere now. So we're talking about, I cannot draw. All right. The best approximation in cubic inches to increase, to the increase in the volume of a sphere when the radius is increased from 3 to 3.1 inches. Okay. All right, I see like what the idea is. All right. So we're going from 3 to 3.1. And when I hear approximation, I'm thinking linear approximation. So the volume of a sphere is 4/3 pi r cubed. So that's like the volume as like, let's think of it as like a function of r. So I'll even rewrite this like this. All right, so it's like v of r. So if I want to know, like using 3, it's like 4/3 pi times 27. And I'll leave the units out for now. But this is 36 pi. So this is like my point, like 3 comma 36 pi. And do we get a... All right, I guess that's not going to matter, but we'll see. So now v prime of r is 4/3 pi times 3r squared, which is 4 pi r squared. So v prime of 3 is, wait, why can't I think? 9 times 4, 36 pi. Wait a minute. Did I say something ridiculous? Give me a second. 4/3 pi v of 3, 4/3 pi times 27. Okay, because the fact that the volume and surface area were the same is like, I was like skeptical for a second. I was like, wait a minute, did I multiply wrong? Because I'm also been awake for a long time and I taught all day. So at the end of the day, like my brain is sometimes like, ugh. So this is our slope and this is our point. So now if we write the equation of a line, it's like y minus 36 pi equals the slope, 36 pi, times r minus 3. So then if we plug in, let's see, y equals 36 pi, r minus 3 plus, and we plug in 3.1. So like the approximation at 3.1 would give us 36 pi times 0.1 plus 36 pi. That though is annoying me. I feel like if it's no calculator, it should simplify way, way, way nicer. Oh, but wait a minute. Are they asking for to the increase in volume? Okay, so the increase in volume, I mean, are they really? Let me just double check something real fast. I'm gonna do something like on a pocket calculator, just to see, because the increase in volume is just one piece. Like, you see how the volume was this? This was the volume. So this is the old volume. This is like the increase in volume. That piece. Okay, the derivative times like that change in the radius. So let me just see something real fast. If it checks out to the same, 36 pi, and then divided by 10, 11.3, 11.3, is that? Give me a minute. Yeah, it's A. Okay. So that's the increase in volume. That's 11 point. In a calculator, that comes out to 11.3097, which is like 11.3 if we round. Okay. If I had to do this like truly with no calculator, it's kind of annoying. I don't know. I guess I would just do like 3.6 times 3.14, like 159 or something. Like, actually take the time, and I'd write this over here. So 3.6 like this. So then like I'd probably just write, like if I really had to suffer, I would say like, all right, 314,159 times 36. And I don't know, I feel like this, like I was like, me and my niece last year were doing questions like this, or 2 years ago. She's in like 5th grade now. All right, so that's 35, 9. Ugh. Yeah, I mean, you could, like, if you want to like remember the old math, like do this, but it's like kind of painful. Placeholder 7, carry the 2, forget that one. 15, 17, carry the 1. 4, 12. Yeah, so like technically we could do this without a calculator, but it's just kind of silly. 12, carry the 1, 17, 9, 10, carry the 1, 13, carry this, 11. And then you'd have to make sense, like, all right, 3 times 3 is 9, so like it's a little bit more than 9, so like 11 point blah, 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 blah. All right, so like if I had to really do this without a calculator, I guess that's what I'm doing. No. This would be, I'm curious, like I'm going to look at classmate solutions and see like if they did it a different way. I might be overlooking something to make it nicer, but like that's the idea. So yeah, just know the formula for L of x is equal to like f prime of a x minus a plus f of a. So this is like the start, and this is like the change. All right, that's how I knew, like, oh, that was the original volume and this is the change. So like they're asking us just for the change. So whatever. Yeah, that's kind of a weird question. But hey, long multiplication works. I should make a quiz on that where I say no calculators, long multiplication, and long division of decimals. I wonder how people would do. That's like a 7th grade test. Fair game. I don't know. So next, all right, I'm sorry. So 17. Ooh, yeah, 17 is rough. All right. So 17, let's see. So we have like M1 is the slope of, and let's go double check something. Let's see what time I am at, because I'm like, I feel like I'm in the zone. Oh, 8:48. All right, that's not that late yet. All right, M1 is the slope. I lost the question. Of xy equals 2, and then we have like m2 is the slope of x squared minus y squared equals 3, and okay, now what we have is like basically at the intersection. So like at the point of intersection, let's abbreviate, at the point of intersection, there's like a few possibilities. Now, I'm just going to show you why, but like the answer is like, I believe like m1, m2 equals -1. Because I remember doing this like the other day, or even today. I think one of your classmates asked this one in class. So yeah, I could take a look at 32 for sure. So this one, at the point of intersection, like it's not always like you have to do things in order, but that tells me, all right, where do they intersect? So that one, I would say something like, let's see, x equals 2 over y. I could do I'll do y equals 2 over x. See, like you solve that for y, divide both sides by x, and then you plug in to the second equation. So this is solving a system. X squared minus y squared equals 3, but instead of y squared, you're going to have 2 over x being squared. So that's going to make x squared minus, and we'll have 4 over x squared equals 3. Now from here, I would multiply both sides by x squared. That's going to give you x to the 4 minus 4 equals 3x squared. And now that is going to give you x to the 4 minus 3x squared minus 4 is equal to 0. And this factors to x squared minus 4 times x squared plus 1 equals 0. Yes. Velocity, acceleration, position problems, sure. Be happy to. All right. I like that we're getting a lot of people now. New people too. So if I haven't met some people yet, welcome to live stream week 10. Remember, if you haven't done so yet, please like and subscribe. And we will do these live streams every week at, I'd say, the neighborhood of 8:15, 8:30. I'm a dad of 2, so it really depends on like when my kids go to sleep. But we'll say like, yeah, 8:15, 8:30 start time. Yeah. So this has no solutions. Okay, this will never equal 0. Like x squared plus 1 never hits the x-axis. So no solutions. But this one, you could set equal to 0, take the square root, x equals plus or minus 2. Okay? So that's coming from like x squared equals 4. Gives us this. But now how that helps us is now we could use that information to solve for the y value. And if you solve for the y value here, notice like when x is equal to 2, y is going to equal 2 divided by 2 is equal to 1. So that means like 2, 1 is a point of intersection. But then when x is -2, y equals 2 divided by x equals -2. So y is -1, which means that the other point on the curve is -2, -1. All right, so these are like the 2 points. But now to like carry this, let me move this stuff down, just this part. Oh, that doesn't just copy. That's annoying. All right, I'll just do that and paste it over here. All right, good. So it followed. So now I could just zoom back in. So then here, now that we know the points involved, we're going to take the derivative of both of these. Remember, the other one was y equals 2 over x. And y prime here would be -2 over x squared. And if I take the derivative of this one, I'm going to use implicit. That would be 2x minus 2y dy dx equals 0. So this would give you, let's see, you'd have 2x equals 2y dy dx, which is really just going to give you x over y equals dy dx. So what we do here is we plug the points in to both derivatives. Like this was, I think, m2, and this one represents m1. So I have y prime evaluated at x equals 2 would give us -2 over 2 squared, which is -1/2. But if I plug into this one, see, I have an x and a y. So dy dx, when x is equal to 2, y is equal to 1, would give us 2 over 1, which is equal to 2. And notice if I multiply m1 and m2, negative 1/2 times 2 equals negative 1. So it checks. Now, some people might say, oh, wait, what about the second point? Well, the second point is going to give us the same thing. So y prime at x equals negative 2, and this derivative is negative 2 over negative 2 squared, which would be negative 2 over 4, which is negative 1/2. But when we plug in here, dy dx at the second point, negative 2, negative 1, is x over y is going to give us negative 2 over negative 1, which is positive 2. Notice the product of those is still negative 1. All right, so it works out. All right. 32, and then oh wow, you know what, 32 might answer that question about 8 feet deep if it's if they're treating depth and height as the same thing. I think they're using the words depth and height interchangeably, but I've seen some questions where like one of the bear traps is that depth comes from the top down and height comes from the bottom up. So I just want to, I don't know. I'm going to double check. So this is like a question I had going into this, but it's annoying, but like this is like more of like a AP Calc resource. So it's like depth. Is that from like top down or bottom up? Like that's the question. All right, it's like a little detail, but whatever. All right, so 32, depth of 20 feet. Oh, I just did a question like this not that long ago. And the radius at the top is 10. And water is leaking out, so the surface is falling at a rate of. All right, so the surface, let's call that the height. dH dt is decreasing, so water is leaking out. Negative 1/2 feet per hour. The rate in cubic feet per hour at which water leaves, so dV over dt. All right, so we want to know what is the rate in cubic feet per hour that the water is leaving when the water is 8 feet depth. So the question is like, is it 8 feet like this? Or if depth is 8, if depth is like a top-down concept, just imagine like if my whole distance is 20, but I go like from the top down 8, that's the same thing as coming from the bottom up 12. All right, so what I'm wondering here is like, am I using h equals 8 feet or h equals 12 feet? Like that would be like kind of annoying if it's the second case where it's 12, but we'll see what their mood is. All right, because these are like the tiny details that like really make the test. That's like the statue detail. If they're like, aha, depth, not height. Depth is top down, so h equals 12. But we'll see. We'll evaluate it twice and see if even 2 answers show up. But the concept you need for this, like I was saying before, is that whatever the water level is, and R and H, the ratio of R over H has to be equal to 10 over 20. So this is like our primary equation, and now we have a secondary equation. All right, so we need to use both. This reduces to a half, and I can say R equals 1/2 H. And now I'm going to plug that in over here. So V equals 1/3 pi R squared H. Instead of R is 1/2 H. So V equals 1/3 pi, and I'll have 1/4, and now H to the third, 1/12 pi H to the third, and now dV over dt equals 1/12 pi 3h squared dH dt. 3 over 12 is a 1/4. So dV over dt equals, we'll have 1/4 pi. Now here's the $1 million question. dH dt is negative half. Okay, feet per hour. Now what's making me think that it's the first one? If they're saying the depth is like, oh, the surface is falling at a rate. So that means like dH dt is negative. Like the surface is falling means the height is dropping. But now the $1 million question is, are we using h equals, let's see. If we use h equals 8, that's going to give us 64 divided by 8 is 8, and it would be 8 pi. But if we use 12, 144, let me just do this over here. 144 divided by 8. Does that go in nicely? Is 18. And that, wait, that's not even showing. That's not even showing up. Okay, so that means they're saying h equals 8. All right, so that depth situation before, I think they're treating depth and height as interchangeable, which is like kind of annoying because it's like sort of a little different, but whatever. All right, so h is 8. And, oh, and this is times like -1/2. So now here, this is going to work out to, wait a minute. Oh, sorry, squared. H is being squared. So I was just like doing a lot of thinking out loud. So 1/4 pi h squared, h is 8, times dh dt is -1/2. I'll leave the units out for now because at the end I'm just going to attach the cubic. So this is times -1/2. And now it's like cubic feet per hour. All right, so that's 64. See, it's like 64 divided by 8. And it's negative, so -8 pi cubic feet per hour. But they're asking like how fast is the volume leaving? So that's why they like, I could say like the minus means that the volume is decreasing. The fact that dv over dt is negative means the volume is decreasing, but because it's built into the language, like find the rate that water leaves, the water is leaving at a rate of 8 pi. Now let's just double check. I hope that's right. Moment of truth. All right, that was 32. Is B. Cool. Works. All right, let's see. So velocity, acceleration, blah, blah, blah. All right, let me just, one thing. I want to double check. All right, so Luis Sanchez, I emailed you one of my questions. I'm making sure I'm answering things in order, but I believe someone asked about motion, or is that, let me see. Why is my chat not moving? Give me a minute. Is this, I'm going to refresh the page. Okay, so we're still, okay. All right, well, I'm going to look at the question that was sent. So a limit. All right, that's nice. Nice limit question. Was it L'Hopital's rule? The limit as x approaches 3 of x minus 3 squared plus sine pi x over 1 over x minus 1/3. Now, the first thing I check here, I plug in 3. And don't write this, because on the AP test, if it's free response, you could get in trouble for, don't write this. Technically, they could take a point off if you write that. So don't do that. You could think it, but don't write it. I'll show you like the nerdy way of writing it so that you don't lose any points. Because there was one year on the AP test that only one kid got a perfect score on BC. And there were like 5 other kids that almost got a perfect score, but they lost 1 point for having bad notation with L'Hopital's rule. So I'll talk about that detail. So 0 squared plus sine of 0 over 1/3. Yeah, this is definitely 0 over 0. Now, if it was the AP test, so AP free response, I would say this. The limit as x approaches 3 of the top stuff equals the limit as x approaches 3 of the bottom stuff, and it's equal to 0. Okay, that's the technical way of saying 0 over 0. All right, like you do a mental check first to see that it's 0 over 0, because don't use L'Hopital's rule if it doesn't apply. That's a common mistake, is people just get excited and they just L'Hopital everything in sight. So I could say, therefore, L'Hopital applies. Because we're showing that the limit is in indeterminate form right now. So now we say the limit, I'm not going to rewrite that, I'm just going to like move it over here, is equal to, by L'Hopital's rule, the limit as x approaches 3 of, and now you have to be awesome at derivatives. Now here's the thing, with this one, if you forget, you could either do, like, if you forget chain rule, you could always expand this, but that's kind of painful. But here we don't actually need the chain rule. And the way I know that is like the derivative of the inside is just equal to 1. So this one is like pretty clean. It's just 2 times x minus 3. Plus we'll have cosine of pi x. Now we have to do chain rule times pi. Okay? Over the derivative of 1 over x. So that one, the derivative of 1 over x is negative 1x to the negative 2, which is negative 1 over x squared. All right, so that piece on bottom is just negative 1 over x squared. And then here, minus a third, the derivative is 0. So now we try plugging in, and this should work. Equals 2 times 3 minus 3 on top, plus pi times cosine of 3 pi over negative 1 over 3 squared. Now what you need to know is the unit circle. Like this is like 0 pi over 2 pi 3 pi over 2, and it brings us back to 2 pi. So I always think like 0 pi, 1 pi, 2 pi, 3 pi is here. That's the point negative 1, 0. Cosine is the x, so it's negative 1. So I have pi times negative 1 over negative 1 over 9. Don't make the mistake of saying, oh, it's being squared. The negative 1 over x squared means the negative is fixed. So just square this stuff on bottom. But now negative over negative cancels, and this is going to give us pi times 9 over 1, which looks like 9 pi. Okay? So that is your limit. A fun question, L-hop. I thought I saw like a... Let me see, who else? Yes, so to the question, so we'll do Q&A for a minute. I'm sorry, I've been very busy this week writing college letters of recommendation, so my background's going to be a little soppy, but Q&A. I mean, I can just answer it here, whatever. But the detail, I would know for the AP test, only because the more fine details you know, that means like you're going to not lose points for annoying stuff. Like one thing I always show my students, calculus course description, and let me say it's like, oh wait, notation. Communication. Here it is. All right, this page. I will take a screenshot of this. So if you all want to talk about the actual AP test for a second, this is huge. All right, a lot of kids that get like a 4 or even a 3, this is the detail that gets them, is this last one. All right, sorry, it's like the best quality screenshot, but whatever. Okay, communication and notation. So what I just showed up there, this detail is communication. Okay, this is communication and notation. All right, that's one of those things where, like I said, I've had students, when I was brand new to teaching this, I was like, how did that student not get a 5? Or how did they not get a 4? And then because I wasn't emphasizing this enough, you know, like stuff like this will get you in trouble. If you're like, all right, f of x equals, not even, like, yeah, like f of x equals this. And then you just write like, okay, and you don't label it. So I know what you're saying. You're saying this. But you have to tell the people grading your test that. Okay? So if you say it wrong, It's like writing an English paper in like all caps. It's like your English teacher is gonna like throw that back at you. Like, I cannot read that. That's garbage. So like when they read that, it's like, oh, it's sloppy. So you could lose points on that. All right, but this is a big idea. You know, you got to be able to. This is like, can you do the math? Do you understand what it looks like in many different forms? You know, so like connecting representations is like, do you know that f prime of x is slope of f of x? Because some people, they're like they just think like, oh, f prime. They're like, I know, power rule. And they're like, oh, I'm like, okay, what else? Power rule. That's all they know. But do you know that the derivative tells you, if this is f of x, that the derivative tells you the slope of the function at any point? Okay, that's connecting representations. That's like knowing what it means in multiple contexts. Justification means you know how to apply. This is massive. This is like basically the biggest part of the test, next to doing like this is like technique, and this is more like concept. Okay, like you know which theorem to use and when, right? So that's kind of the direction it goes. Yeah, I'm happy to take general questions now. Oh wow, 9 concurrent viewers. So once again, thank you to anybody who's here. And if you are here and you have not subscribed, I'll turn that little visual thing, the media source, is that this? Yeah, I'll click that out for now. But general questions from the chat. Any other like content, well, like motivation questions or what's the test like questions? Because I've been teaching AP Calculus. I should count. Let me see. Because I need to have like an official. So the first group I led was like, 2015 was the first year I had kids take it, but I took over in the spring. So I was like half a year I was the AP Calc teacher. Then 16, 17, 18, and I believe 19. But this year, 2020, I was skipped. Okay. So this one I didn't teach AP Calc because my kid was born. So because I was going to be, I went on paternity leave. So that year I didn't, run the class. So I missed out that year. 2021, I taught AP Calc. And I led 2022. And I'm currently leading, that's all of you. So this is all the years. So let's see, 1, 2, 3, 4, 5, 6, 7. This is my 8th group leading to the AP test. This one I had them like half a year. Okay, so I had them half the year. So yeah, it's been a fun ride. It's fun to be able to say that now too. Like 8 groups I've led to the AP test. So except my first year and the year my first kid was born. So 2020, I missed out, but it's quite all right. So any other questions here? And it doesn't have to just be calculus. If we have anybody here for algebra, geometry, or trig, happy to help. Okay, so let's see. So any tips? Let me get the, I'm going to do a little chopping here. Let me see. Switch to my Japanese. I recently did a video on the Japanese temple problem. Let me get the chat thing set up, that chat extension. Let's see. All right. And just give me 1 minute to pop the chat out. And I will kind of bring this one out for now. And let's see. All right, just give me a minute because I like when the questions show up. Display source. No, I'll do media window capture. Sorry, just thinking out loud. Oh, here it is. Okay. So So I got this. Let me just shrink this down. Sorry, I'm supposed to do this before you all get here, but this live stream is the best. All right. Okay, so this, and drag this down. You know what I'll do is I will add a chroma key, color key, so it cuts that excess out. So filters, color key, and custom. All right, here we go. I think we are in business. All right. And let me make myself more jumbo. All right, here we go. So now, move this here. Oh, and I will drop this down a little bit more. Perfect. So arithmetic. Now, the general arithmetic, I would say, is like just practice. It's, I'm trying to think, like number sense. I mean, you could always go back to number sense, like those cool divisibility tricks. Like there's a lot of cool things that you can learn. But I would say you would want to focus more on, like, what do you do when you forget steps to solve a problem? So that, I would say, comes from really understanding the theorem, like massively. Like people, I think, really underestimate how important it is to know why the theorems work. You know, like if I know I just switched to this, but now I'm going to switch back to this view. So I'll go back to good notes. Is like, let's say the first derivative test. So remembering the steps is, for me, very possible because I know why the theorems work. So like this, I think visually you could see if this is f of x. I think we could all see, like, all right, that's a local max. And this is a local minimum. So like, how do I remember the steps to finding local maxes and mins? Because I would say, all right, f prime, sign chart, and then I'm like, all right, plus to minus is a local max. Local max. And if the derivative goes from negative to positive, local min. All right, like that's what we're looking for. But I remember that because I understand why that needs to happen. Like you see here, the slope before the top of the hill is positive, and then after the top of the hill, it's negative. And then at this location, when we have a local minimum, the function is decreasing, so it has a negative slope. Then it has a zero slope, and then it has a positive slope. All right, so like that's why I remember the steps, is because I know why the theorem works. So this is more intimidating, but you want to, for a lot of these theorems in calculus, you want to investigate them. You want to draw them out. You want to ask yourself, why do they work? You know, the frustrating part of that is that, like, you know, I was a math major, is that eventually math gets to a level where you just can't, like, do that anymore unless you're the professor. And then even so, there's professors that don't know why the theorems work. So it's, yeah, it's like kind of one of those, like, ugh, it's like just frustrating. So yeah, if I had to say remembering the steps, the best answer to that is understand why the process works, because then you don't forget the steps. You could make up the steps. You could do it like 10 different ways, you know. That's my best advice for that. Like, another one is chain rule. Like, why is, like, let's say, I don't know, the derivative of like sine of f of x. Why is it f prime of x cosine of f of x? You know, so like me, like, I understand the process of finding the derivative by chain rule, and I could do it in a really annoying way. Like, I could do like there's like a u substitution method. I could say, all right, u equals f of x. So then du dx is f prime of x. And then I could say y equals sine of u. So dy du equals cosine u. And then here, the chain rule in Leibniz notation is this. So if I want to find the derivative dy dx, I'm just multiplying dy du by du dx. Du dx is f prime of x. And then cosine of u, that's dy du. I just kind of like flip these here so that it looks nicer. And then u is equal to f of x. You see, so like I know how to like, I don't want to say prove that, but I like Leibniz notation. This is the long way. Okay, so this is like the long way to do chain rule, but mechanically, like it makes sense, and it transfers very well to u substitution for antiderivatives. It transfers very well to differential equations, and then for those of us like MG Pablo, hello, taking multivariable calculus, like Leibniz notation makes an appearance there as well. So you're learning something more difficult by doing it the long way, but you're going to be more likely to understand the process, and then you won't have to memorize a million chain rule formulas. Like you'll just really understand why the chain rule works, and then you're less likely to forget the steps. Okay, so understanding is key, like 100%. Like the way I teach in my class is like I spend a decent amount of time saying why does it work? So yeah, but all right, let's see. So let me pop out the chat again. If I switch back to Q and A, so let me turn this off for a second. Display. I am probably going to sign out in a few. All right, let's see. So this back to here, and let's see, blah blah blah. Cramming for your first midterm. So for one, good luck. I hope it goes well. Confident in getting the 100. Very nice. And a senior class who took it last year said the exam is easier than the review. Very nice. So then the odds are in your favor. So MG Pablo, do what you do best. Once again, I think it's pretty remarkable that your school offers multivariable calculus. I'm kind of jealous that it's an option like for you to take. So, all right. Let's see. Derivative of inverse problems. All right. I could do, what time is it? I could do, almost all of higher math theory. Yeah, very nice. Like I said, I'm inspired by the people I'm meeting in this chat to maybe go back out there and learn multivariable calculus and relearn like differential. I think it would be fair to say I could relearn differential, linear algebra, and Calc 3. Maybe partial differential, but I don't know. I mean, I'm just going to see where it takes me. I like I said, I'll probably stream it over the summer. Like when I'm learning it and struggling, like I'll just put that all out there, like me thinking. So like you could all even see how I learn math, because as like the teacher, you kind of have to learn it yourself depending on what you're teaching. Like if you're teaching something that 5 other teachers teach, then you have people to talk to. But like I'm learning, like I teach Calc BC, but I'm the only one who teaches it at my school. So like when I had to relearn it, because it was like 10 years out of Calc 2, I had like myself, and I would watch, like I would like read old textbooks, watch old lectures. And I watched like 3 different lectures just so I could put my own twist on it. Like I find like my own style to the question. But yeah, it's a lot of fun learning this stuff. It's definitely like, I know some people don't see it as a privilege, like, oh, I have to do this, but like, it's like, no, you get to do this, like that's just a gift in itself. All right, let me do control find and then write inverse. So derivative of the inverse. All right, and let me switch my view back to this, return the chat, and this will be the last thing I do. All right, so sorry to anybody new after this, but I will say this is going to be my last topic to cover, is derivative of inverse. All right. Now let me pick one that's, let's see. I mean, I could pick one that's like kind of, I want to say straightforward, but all right. Well, for one, you have to know the formula. Derivative of f inverse, and let me make sure my stuff isn't out of whack here. I am display off, so first let's do that. So here, f of x, I'm sorry, f inverse of x. The derivative is 1 over f prime f inverse of x. Now, if I had to prove this, what I would say here is know the definition. So this is like, oh, what are the steps? Like, I know how to prove these formulas. And when we get here, I would take the derivative of both sides. And chain rule, derivative of the outside, keep the inside the same, times the derivative of the inside is f inverse prime. And the derivative of the right is equal to 1. So if I'm solving for just this, I'm going to divide both sides by that. Okay, so in the next line, I'll have f inverse prime of x equals 1 over f prime f inverse of x. Okay. So now that we have this, what I want to do is we will answer the question. Let me just pick one that's like kind of, I'll pick one that we could solve both ways. So let's say f of x equals x to the third minus 4, and we want to find f inverse prime of 23. So something like this. So there's two ways you could do this, and I got to add a page. Okay. The first way is use the formula. So when you have this formula, f inverse prime is 1 over f prime f inverse of x. I just drink a little water. Talking too much. All right. I hope that didn't freak out my camera. Sometimes when I do that with the green screen, it like just totally wrecks the camera, but whatever. So here, a little side math to know is I'm going to set the function equal to 23. And you'll see why in a minute. 23 equals x to the third minus 4. Add that, you'll get 27 equals x to the third. And then that'll tell you x equals 3. Now the reason I do this is because if f of 3 is equal to 23, remember the relationship between like xy goes to yx. All right, like an inverse function as a concept, like you have f inverse is like the reflection over the line y equals x. So if f of 3 is 23, f inverse of 23 is equal to 3. All right, this is big. All right, this is a very important detail, because if we want to find f inverse prime at 23, now we have 1 over f prime f inverse of 23, but we just found f inverse of 23 is equal to 3. So this is 1 over f prime of 3. And now I just have to find what is f prime of 3. Well, if f of x is this, f prime of x is 3x squared. Let's make that neater, 3x squared. So f prime of 3 is 3 times 3 squared, which is 27. So this becomes 1 over 27. There's our answer. Now, the second way to do this is not always an option. Okay, this is most likely, okay, well, I'll just say, most likely how it will appear on the AP test, because I got to get moving here. Option 2, which is not always going to be an option. They will give you a table of values and remove that, but I could solve for the inverse. Okay, so I take f of x, and I solve for the inverse directly. This is x plus 4 equals y to the third, which tells us y equals cube root of x plus 4. So if I do it this way, then we could just find, this is f inverse. So we'll just say like, yeah, y equals f inverse. So then I'll say here f inverse prime of x as a function is now, this is to the 1/3. So this is like x plus 4 to the 1/3. Is that this is 1/3 x plus 4 negative 2/3. Derivative of the inside is 1. So it doesn't matter. And this is 1/3 cube root of x plus 4 squared. Okay, and now we're plugging in 23. So what is f inverse prime of 23? It is 1/3 times the cube root of, and we have 23 plus 4, that's 27 squared. But just know, I don't have to square it, then take the cube root. This is the same thing as 1/3, and I have the cube root of 27 squared. Same thing. So this is 1 over cube root of 27 is 3, and 3 squared is 9. So also 1/27, same answer. All right, but option 2 is most likely not going to be an option. They're going to force you to use the formula directly. All right, cool. So let me just scan the chat one last time. I don't know why it's kind of freaking out a bit. Why is it going slow? Hope I didn't lose people already. All right. So yeah, this is going to wrap things up. Let me just see here. I'm gonna have to cut it at this point here. So yeah, Zeta hates YouTube. Sorry to disappoint. I do have to get moving here. What I can say though, write the equation of a line tangent to f of x. Oh, you know what? Hyperspeed. F of x. So hopefully this is informative. All right, f prime of x. This is x to the half equals 1/2 x negative half 1/2 radical x. This is absolutely the last one. At x equals 9. So f prime of 9 equals 1/2 radical 9. 1/2 times 3. 1/6. F of 9, also plug into the function, is square root of 9 equals 3. That means your point is 9, 3. And this is your slope. This is your x1, y1. So now you write the equation of a line. Y minus y1 equals slope x minus x1. And approximate square root of 8. So if you are approximating the square root of 8, so we are using local linearization at this. Okay, so square root of 8 would mean plug in x equals 8. All right, so this is y equals 1/6 x minus 9 plus 3. So if we're approximating square root of 8 is roughly equal to, you see how that corresponds to like x equals 8. That would give us square root of 8. So plug in x equals 8. And so we see here square root of 8 is roughly equal to 1/6 8 minus 9 plus 3, and that's going to give you -1, so you'll have 3 minus 1/6. All right, so whatever that works out to is a decimal. If you had to do it by long division, you could. 6 goes into 10, so it goes into 10 once, remainder 4, then it goes in 6, remainder 4, so it looks like this, 3 minus 0.166, like that, which would be, let's see, 0.166 minus, so 2, make it a 10, borrow, make it a 9, 10, borrow, make it a 9, and that's 4, 3, 8, and 2, 2.834. Yeah, so 2.834. All right, that's all I got. Now I'm finished. So yeah, to everybody, I'm just gonna say, algebra question. All right, I'm like racing the comments. 2x, 4x to the second plus x minus 5 equals 0. All right, hyperspeed. Hopefully this makes sense. AC, this is your A term, this is your B term, this is your C term. 4 times -5 is -20. Your B term, the number in front of x is 1. So now you ask yourself, what two numbers multiply to this and have a sum of this. That would be 5 and negative 4. You split the middle. Okay, 4x squared plus 5x minus 4x minus 5 equals 0. So these numbers that make these two work, rewrite the x term. Then you factor by grouping. Take out an x, you've got 4x plus 5. Take out a minus 1, you also have 4x plus 5 equals 0. Now you have x minus 1 times 4x plus 5 equals 0. And set these equal to 0. Set this equal to 0. X equals negative 5 over 4. X equals 1. Finished. All right. That's the last question. So, Candace Armstrong, I hope that helped. I normally don't explain things at hyperspeed, but I was supposed to clock out a minute or so ago. But yeah, take care, everybody. Happy Wednesday, and I'll see some of you, maybe all of you, next week. Take care.